There we have come across the definition of chemistry with respect to a matter. We got its composition, structure, properties, and the changes it undergoes when it reacts with other matter. Not only that, even when we think about a matter, its related terms were recalled. That is, it may be the atom, it may be the molecule, it may be the structure of the atom, even the compound, is it not? And not only this, with respect to an atom, we got very good information. Just once you recall the definition of an atom, it is the smallest particle of an element which can take part in the chemical reaction. This is the atom, and it is the building block of an element. And even we have come to know the structure of an atom. Every atom consists of three kinds of particles. And these three particles are called subatomic particles of an atom or fundamental particles of an atom. They are, one is proton, second one is neutron, and third one is electron. Among these three, protons and neutrons, they are in the central part of an atom where 99% of mass of an atom is concentrated, which is called nucleus. And other particle, that is electrons will be revolving around the nucleus in different orbits, different energy levels, which are called shells. And even we have come to know the common name that we use for protons and neutrons, it is nucleons. Then the number of protons present in the nucleus of an atom is called, what it is? Atomic number. Even atomic number will give us information about how many protons are there in that atom. Not only that, even the number of electrons as well. Whatever the electrons are there, these electrons are arranged in different energy levels called shells, and this arrangement is known as electronic configuration. That is, the arrangement of electrons in the various shells of an atom of the element is called electronic configuration. Even yesterday we recorded the electronic configuration of the elements whose atomic number from 1 to 20. With that information, we have come to know the valence electrons, valency, even the charge as well. If you want to recall any one of these, like magnesium, I've taken magnesium atom, the number of protons in it, it is 12 because its atomic number is 12. Then how many electrons will be there in one atom of magnesium? It is 12 only. And the arrangement of these 12 electrons can be written as, in the first shell, 2 electrons, second shell, 8 electrons, third shell, 2 electrons. Altogether, total 12 electrons. Here, the number of electrons in the outermost orbit is 2. And this 2 is known as valence electrons. The number of electrons in the outermost orbit of an atom of the element is called valence electrons. Here, 2 valence electrons are there, and these electrons are responsible in taking part of chemical reaction. Then, here, we know that most of the atoms are unstable. For attaining the stability, they have to have octet configuration. That means they must have 8 electrons in the outermost orbit. Is it not? Then how does an atom attain the stability? There are 3 possibilities. One is either by losing the electrons or donating the electrons, or by receiving the electrons. Third one is by sharing the electrons. And this is possible that an atom can donate the electrons if it has less than 4 electrons in its outermost orbit. An atom can gain the electrons if it has more than 4 electrons in its outermost orbit. then an atom can share the electrons if it has 4 electrons in its outermost orbit. Here we have only 2 electrons, less than 4. Therefore, it loses 2 electrons. On losing 2 electrons, it attains the stability. When an atom loses its electron, we can call it as that atom is charged. So then the charged magnesium atom can be written as it is Mg2 plus because it has donated 2 electrons. Similarly, when we come across atom like oxygen, its atomic number is 8. Its electronic configuration is 2, 6. See that here there are 6 electrons in the outermost orbit. So this atom is ready to receive 2 electrons for attaining the stability. So after receiving 2 electrons, then it gets charged, and we will write it as 2 minus. As it has received 2 electrons, you can write it as O2 minus. Similarly, another one, carbon, its atomic number is 6, electronic configuration is 2, 4. There are 4 electrons in the outermost orbit. It needs 4 electrons for attaining the stability. It has the half of the stability. It neither loses the electron nor gains the electron. Instead, it will go for sharing it electrons. It shares all of its 4 electrons with the 4 electrons of other atoms. On sharing, it gets charged and we write it as C4 plus. In general, the charged atom is called an ion. Charged atom is called an ion. There are 2 types of ion. One is positively charged ion is called cation. Negatively charged ion is called anion. Yesterday, we had listed both cations and anions, right? And even we have come to know how to write the formula of the compounds using crossing over valencies or crossing over charges. Then what is a compound? You know that compound, it is formed by 2 or more elements combined chemically with a definite proportion by mass. Once I repeat, if 2 or more elements combine chemically with a definite proportion by mass, then it is called a compound. Here, some compounds are formed by the ions. So, yesterday, just I had shown you how to write the chemical formula of few compounds. I'll go for taking some more, just observe, and even you may copy that. Just I'll give you only 5 to 6. First one I'll take magnesium oxide. You may also write with me. Magnesium. Yesterday I think we have taken 2 compounds, right? Is it not? 2 are taken. Now it is third one, magnesium oxide. By crossing over valencies or charges, you can write like this. Here the elements involved are, one is magnesium and another one is oxygen. Their charge Mg 2 plus O 2 minus. Crossing over charges, it will be Mg2 O2. As the same number of atoms are there, you can write just MgO. Followed. Next, another one. It is sodium oxide. Sodium oxide. And we taking only the compounds which we come across in the very first chapter. Even yesterday in worksheet also, I've given all the possible compounds. Sodium oxide. Here, the ions involved are, one is sodium ion, this is Na1 plus. Next, oxide ion, this is O2 minus. crossing over charges, we can write like this. Chemical formula of sodium oxide as, see that, Na2, then O1, Na2O. Next, I'll go for taking one more. This is aluminum oxide. Aluminum oxide. Here, the ions that are present in this compound are, one is Al3 plus aluminum ion, and next one is oxide ion, that is O2 minus. Observe crossing over charges. You can write it as Al2, then O3, Al2, O3. Next, I'll take one more. It is aluminum sulfate, or you may take, let us go for taking zinc sulfate. Zinc sulfate. The ions involved are, one is zinc ion, that is Zn2 plus. Next, sulfate ion, it's a compound ion. Sulfate ion is to be written as SO4, 2 minus. Then crossing over charges, you can write Zn SO4, Zn SO4. Then next one. I'll take sodium sulfate. Sodium sulfate. The ions that are involved are, one is sodium ion, can be written as Na1 plus. Sulfate ion, it is SO4, 2 minus. Crossing over charges, you can write the chemical formula of sodium sulfate as Na2, then SO4, Na2, SO4. Got it? Similarly, you are also very familiar with copper sulfate. Copper sulfate. It is, the ions involved are Cu2 plus, that is copper ion. Next, sulfate ion, SO4, 2 minus. Here also crossing over charges. Here the charges are same and opposite and inside. You will go for cancelling both, +2 and -2. Then it will be CuSO4, copper sulfate. This is the chemical formula of copper sulfate. Apart from this, some more which is there in your textbook. Could you tell just to recall the chemical name of washing soda? What is that chemical name? Chemical name of washing soda is sodium carbonate, right? Sodium carbonate. And baking soda, it is sodium bicarbonate, which you have come across in 9th standard only. Is it not? So I'll go for taking both. The washing soda is nothing but sodium carbonate. Sodium carbonate. The ions that are involved are, one is sodium ion, that is Na plus, and carbonate ion. Rahul Palate, what is the carbonate ion? It is CO3, 2 minus. CO3, 2 minus. Crossing over charges, you can write it as Na2CO3. Then here one is there, no need to write. Just Na2CO3, sodium carbonate. I'll go for taking another one. This is calcium carbonate. It is also important for us. calcium carbonate. Right, quick as possible. Calcium carbonate. The ions are, one is calcium ion, which is Ca2 plus, and carbonate ion, this is CO3 2 minus. Then we can write the chemical formula by crossing over charges as it is Ca2, CO3 twice. Here, charges, we have 2 plus and 2 minus, no need to go for considering them. Directly you can cancel, right remaining. It is CaCO3. I'll go for taking another one, that is baking soda. Baking soda is, it is sodium bicarbonate, nothing but sodium hydrogen carbonate. Here, right, sodium bicarbonate. Sodium bicarbonate. The ions are sodium, that is Na plus, and bicarbonate. Recall the bicarbonate ion. Neha Anjimat, Varsha MS. Bicarbonate. It is HCO3 minus. That is 1 minus. Then crossing over charges, it can be written as NaHCO3. This is sodium bicarbonate. Let me go for taking another one. You are also very familiar with the chemical formula of quicklime. What it is? Quicklime. What is the chemical name of quicklime? Quicklime, I have told the common name, and its chemical name is calcium oxide, right? And this can be written like this: calcium oxide. It is Ca2 plus, then O2 minus. By crossing over charges, it can be written as CaO, calcium oxide. This compound will also be used in the very first chapter of this academic year. Next, another one, slaked lime. Slaked lime. What is its chemical name? Its chemical name is calcium hydroxide. Is it not? Varsha MS. It is calcium hydroxide. Right. Calcium hydroxide. Then the ions can be written as Ca2 plus, calcium ion. Next, hydroxide ion. It is OH1 minus. Then crossing over charges, it can be written as CaOH twice. See the Ca1, OH twice. Have you written? Rahul Palate. One more. I think you might have come across the compound what I am going to tell you now. It is lead nitrate. Have you heard about lead nitrate? Deepashri, have you heard lead nitrate? Very good. Tejas B. Kondaji, lead nitrate. Yes. Karthik, do you know about lead nitrate? Yes. Pranati? Okay, most of you are very familiar with lead nitrate. It is lead nitrate, and its chemical formula can be written like this. First, let me write the ions. The ions are, one is lead. It is Pb. Lead ion, Pb. 2 plus. Nitrate. It is NO3, 1 minus. And by crossing over charges, it can be written as Pb, NO3 twice. Followed? Okay, I think this much is enough. And I'm going to write some chemical formula of some compounds. which you are also very familiar with these compounds. Some more compounds. One is hydrochloric acid. You are all very familiar with that. It will be written as HCl. Please write like this only. Not either like this or don't go for using all as capital letters. Hydrogen, capital H, then Cl, capital C, small l, hydrochloric acid. Then other than that, sulfuric acid, it is H2SO4, right? You are very familiar with that. Next, sulfurous acid, it is H2SO3, sulfurous acid, which is present in our atmosphere. You have learned about acid rain. There you have come across, it is the one of the acid present in the atmosphere due to the reaction between the water and nitrogen dioxide, sulfur dioxide. Next, another one, nitric acid. So, honey, recall the formula of nitric acid. Here, it is HNO3, nitric acid. Next, and take carbonic acid, which is a weak acid. This is H2CO3, carbonic acid. Then apart from these, even you are also very familiar with some other compounds like water. Most familiar, it is S2, carbon dioxide. This is CO2. Then carbon monoxide. This is CO. And could you tell one of the chemical which is the main component of CNG, compressed natural gas? Yaudu? This is methane. Methane is the main component of CNG. Methane, its chemical formula can be written as CH4. Next, one of the main component of LPG, liquefied petroleum gas. What is the main component of LPG? It is butane. Butane. That's new. 8th even in 9th also. So butane is molecular formula is it is C4H10. And you are also very familiar with glucose. This is C6H12O6. Next, you are also familiar with some of the bases like sodium hydroxide. Its chemical formula is this is NaOH. Then it is sodium hydroxide. Next, barium hydroxide, BaOH twice. Please do remember all these. Calcium hydroxide, just we have written that here, CaOH twice. Then you are also very familiar with potassium iodide. Potassium iodide can be written as it is Ki, right? Potassium iodide. K1 plus I1 minus crossing over charges. You'll get K1 I1 can be written directly as Ki. Like this, plenty of compounds are known to us. Yesterday, what I had given, what are the compounds I had given in the worksheets? I think they are enough for first chapter. Adishtu new correct practice madidre, it's enough. Okay. Dear students, we got very good information about the basics of chemistry. Now we are moving to the actual chapter in this chemistry. Now I'll go for rubbing it. Shall I? We should. Okay.
Good morning, everyone. Here is the information. So this will be acted from tomorrow onwards. So the class will start at 5:50. Okay, exact 5:50. Before 5 minutes, you have to join. Before 5 minutes, you have to join. The link will be sent at 5:40. Within 10 minutes, everyone has to join. This is the final warning, everyone. So those students who are not going to turn on their video, they are going to remove from the meeting. It is not my responsibility. And don't call me and don't ask me. So this is the final warning I'm giving to you. And some students, they are texting me like, sir, my name is not in attendance. It is your responsibility and yours mistake, not mine. Clear? So please, everyone, turn on your video. Always turn on your video. We are not going to do anything. Okay, we have to see you on screen. Sir, thank you. Sorry, you can continue, sir.
Okay. Okay, dear students, let us commence the very first chapter of chemistry. And before going to that, just let's recall the chemical change. We know that those changes in which new substance is formed, and which is called the permanent change, where the initial substance loses its identity, is it not? So every day we come across many chemical changes in our day-to-day life, right? It may be in your home, outside the home, even in your school laboratory as well. Just to recall some of the chemical changes that you will observe every day. The very first thing, very simple one. In your home, your mother will prepare the tea. Then what are the ingredients she is going to use? Prepare the tea. They are tea powder or tea leaves, then milk, water, sugar. They are to be taken in the container. Then it is to be boiled. After boiling, we get a new substance which is called tea. Whether it is chemical change or physical change, it is a chemical change, because using that tea, you cannot get back all those ingredients. It is permanent change. Once the tea is prepared, you cannot get back its ingredients. Similarly, when any food is cooked, then after cooking, is it possible to get back the ingredients used? After preparing the rice, is it possible to get back rice grains? Not possible. It is also a permanent change. And we will go for using the fruits. And in fruits also, you'll come to know that some are about to ripening, some are ripened completely, and some are much ripened. Is it not? Just here, I'm going to show you a chart. You just observe and tell what it is. They're all, yes, bananas. Do they look like banana? I tried my best to draw it. See that first one. It is not ripened. Observe, it is light green color. If it is kept open for a day or 1 day or 2 days, within 2 days, it will turn to yellow color. It is ripened. Then if again it is kept open for 1 more day, then the banana, it becomes like this. That is, it is much ripening. And if it is kept for 5 to 6 days, if it is not preserved, and if it is kept for 5 to 6 days, then it will turn to almost black color, which indicates it is over ripening. After getting this over ripening banana, is it possible to get back this banana? No. Why? It has undergone the permanent change. Once the substance is changed, we won't get back the same substance. Not only that, I'll give you some more examples. Okay. Well, before cooking the food, we'll go for on the gas stove. Is it not? There, a fuel is being burned. What is that fuel? Just I told you that it is butane. LPG cylinder irutte alva. In LPG cylinder, the fuel present is butane. When the spark is touched to that, immediately it catches the fire. This butane after burning, it produces the compounds What are those? Carbon dioxide na gas release ಮಾಡುತ್ತೆ, even the water vapors also. Are you all following? When butane, that is C4H10, when it is burned, it produces carbon dioxide and water vapors. In addition with that, so these are the things that we observe in our day-to-day life in home, outside the home. See, when you observe some of the buildings which are constructed partially, so iron rods are kept open to the atmosphere, right? What will be the color of, if those iron rods are not maintained, what will be the color of the iron rods? They turn after some days, it will be red brown. So we say that it is because of the rust, is it not? And that iron rod get rusted as it comes in contact with moist air. That is, iron, when it comes in contact with oxygen, carbon dioxide, then water vapors present in the atmosphere, then you'll get rust. What is the chemical formula of the rust? It is Fe3O4 X H2O, right? It is hydrated iron oxide. Not only that, even I'll give you some more examples. When you go for burning any object, it may be the paper, it may be the wood, at last you'll get ash. Usually it will be black in color. Then what is whether it may be paper or its wood, they consist of maximum amount of carbon. On burning, what will happen? They react with oxygen present in the atmosphere and produces carbon dioxide, right? Look here. These are all the examples for some examples for chemical change. In all these chemical changes, you can come to know that the initial substance will lose its identity, and whatever the new substances are formed, they attain their own properties, and the properties of these new substances are different from initial substances. Followed? So these are the chemical changes in which new substance is formed with new properties, and we call this entire process as chemical reaction. Followed? These are all some examples for chemical reaction. Then how can we define chemical reaction? Chemical reaction is nothing but chemical change. Whether only one substance may undergo permanent change, more than one substance may undergo permanent change. If one or more substances undergo chemical change to form one or more new substances with new properties, this is known as chemical reaction. Are you all following? Prajwal, Hriday, have you followed? Okay, one side time. Listen carefully. The process in which one or more substances undergo chemical change to form one or more new substances with new properties is known as chemical reaction. Dear students, now we are going to discuss the very first chapter in chemistry, that is, recall the name of the chapter? It is chemical reactions and equations. Equations, let us discuss that in the later part of this chapter. Now you may write the name of the chapter in regular pattern. That is, right, chemical reactions and equations. Chemical reactions and equations. Written up. Now, First, I'll give you the definition of chemical reaction. Afterwards, I'll go for giving you more information about it. Right. Side heading. Chemical reaction. Chemical reaction. Right. The process in which one or more substances undergo chemical change to form one or more new substances with new properties is known as chemical reaction, or is called chemical reaction. Once I repeat, the process in which one or more substances undergo chemical change to form one or more new substances with new properties is known as chemical reaction. We can give plenty of examples for chemical reactions which we come across in our day-to-day life. That is ripening of the fruits, digestion of the food. Then our respiration is also an example for chemical reaction. Digestion is an example for chemical reaction. Turning of milk to curd is an example for chemical reaction. These are few examples. I'll write one among them. It is when carbon reacts with oxygen, that is on burning it reacts with oxygen to produce carbon dioxide. Carbon dioxide ಯಾವಾಗ ಬರುತ್ತೆ ಅಂದ್ರೆ when it undergoes complete combustion. When carbon reacts with oxygen completely, when it undergoes complete combustion, then it produces carbon dioxide. If it undergoes partial combustion, then it produces carbon monoxide. Please do remember. Observe. In addition with that, I'll go for taking one more. That is methane. Methane, it reacts with oxygen. That is on burning, it reacts with oxygen, produces carbon dioxide and water vapors. And let me go for taking one more example, which is very familiar to you. Dear students, what will happen if sodium metal is put on the surface of the water? We know that the vigorous reaction takes place. You may recall the activity that you conducted in 8th standard. You'll take a beaker, in that some amount of water is to be taken. Take a dry sodium metal, place it on its surface. Immediately, the vigorous reaction takes place. It starts whirling along the inner wall of the glass beaker. Is it not? At the same time, the gas will be coming out. So we can write that reaction as sodium reacts with water. Sodium reacts with water to produce sodium hydroxide. Sodium hydroxide plus whatever the gas is liberated, it is hydrogen. Hope that you have written. Now observe it. Observe. Sushant, have you copied? Sushant SB, have you copied? Okay. Look here. Dear students, you can observe that in all these chemical reactions, there are substances which have undergone the chemical reaction, and there are new substances that are formed as a result of chemical reaction. And we have given particular names for these. So, look here. Here, carbon oxide, methyl oxide, sodium, and water. These are the substances which undergo chemical reaction. And those substances are known as reactants. Got it? Once I repeat, the chemical substances which undergo chemical reaction, the chemical substances which can take part in the chemical reaction, the chemical substances which are involved in the chemical reaction, they are all called reactants. Don't write, just observe. These are reactants. And when they undergo chemical reaction, they form the new substances. Look at here, carbon dioxide, water, sodium hydroxide, hydrogen. These are all new substances. And these new substances are known as products. Please don't write, just look at. These are all products. Once I repeat, the new substances that are formed as a result of chemical reaction are called products. Once I repeat the definitions of both, the substances or the chemical substances which undergo chemical reaction are called reactants, and the chemical substances which which are formed as a result of chemical reaction are called products. Clear? Did you understand? Okay. Then you all may be thinking that, sir, how can we come to know whether a chemical reaction has taken place or not? You will observe many things. And sometimes we'll be unable to identify whether it is physical or chemical change. Under such condition, how can we come to know whether a chemical reaction has taken place? Dear students, to know that or to identify the chemical reaction, we have some of the criteria. Nothing but we have some of the characteristics of chemical reactions. So now we will come to know these characteristics. Before that, just I'll give you information about, I'll give you the definitions of reactants and products and one experiment with respect to chemical reaction. So right, side heading, reactants and products. Right, reactants and products. Reactants and products. Write the definition. What are reactants? The chemical substances which can take part in the chemical reaction or which undergo chemical reaction. They are called reactants. The substances are chemical substances. The chemical substances which undergo chemical reaction, are called reactants. Next, below that, you have to write the definition of products. See, products, these are the new substances, or these are also chemical substances that are formed as a result of chemical reaction. Right? The new chemical substances, which are formed or which are produced during the chemical reaction, which are formed as a result of chemical reaction are called products. called products. So let me go for taking the symbolic representation of any one of these chemical reactions. 3 chemical reactions for the day. I take the last one. Sodium. Sodium, its symbol is, chemical symbol is Na. Water. This is H2O. Then sodium hydroxide. We are very familiar with this compound. Formula of this compound. This is NaOH plus hydrogen. You can write H2. Here, sodium and water, these are called reactants. Then sodium hydroxide and hydrogen are called products. Reactants and products.
Sir, unmute your audio, sir.
Sir, unmute your audio, sir.
Yes, sir.
Sir, unmute your audio.
Oh, okay, sir. Okay. Deepti, can you hear me? Okay, right. Dear students, for the examination point of view, they may ask you the question like this. What is a chemical reaction? Then give an example. Next, what are reactants and products? Then identify reactants and products in the following chemical reactions. Are you clear? Then apart from this, they may ask you the question like this. Explain with a neat label diagram to show the reaction between the two chemicals. Are you clear? So here I'm going to take the textbook example only, and I'll explain one experiment which has been given in the textbook. Here we will take the reaction between magnesium and oxygen, or else the burning of magnesium, we know that it is an example for chemical reaction. Let us frame the question as, show that burning of magnesium is a chemical reaction. Right. Right. Write it as a question. Explain the experiment. Explain the experiment to show burning of magnesium ribbon or magnesium metal. To show burning of magnesium metal. Magnesium metal is a chemical reaction. Chemical reaction. Burning of magnesium ribbon is a chemical reaction. Observe. Dear students, you are very familiar with the metal called magnesium, right? What is the color of magnesium? Magnesium metal? Yes, we know that most of the metal's color is silvery gray, except a few, like gold, it is called yellow metal because it is yellow in color. Then copper, it is called brown metal because it is brown in color. But apart from this, remaining, most of them will be in silvery gray color. Even magnesium ribbon, magnesium metal is also silvery gray in color. And before burning this magnesium ribbon, it is to be rubbed with a sandpaper. Then why, you all may be thinking that why it should be done so. The reason is when assume that this is the magnesium ribbon, when it is kept open, what will happen? It will slowly react with some of the chemicals present in the atmosphere and forms a thin layer of a basic magnesium carbonate. Nothing but it is a combination of magnesium carbonate and magnesium hydroxide. Are you all following? You magnesium ribbon, general magnesium ribbon some dark cement color covering can be seen. It is because as it reacts with moisture in the atmosphere, it can react with oxygen, water, and carbon dioxide. When it reacts with oxygen, carbon dioxide, and water, here it produces a compound called the basic magnesium carbonate is nothing but MgCO3 plus MgOH twice. So as the coating is there, if you go for burning, it won't burn. So as a result of it, it is to be removed. We will go for using the sandpaper. So we will take a magnesium ribbon and it is to be rubbed with a sandpaper to remove the basic magnesium carbonate so that it can readily react with oxygen while burning. Got it? Look here. Here, I'm showing you one more chart. In this chart, you will come to know that we have used Bunsen burner. Then this is magnesium ribbon, whose coating is removed by rubbing it with sandpaper. Next, and it is to be fixed in the test tube holder. This is test tube holder. Next. So after removing the basic magnesium carbonate present on the magnesium ribbon, it is to be fixed in the test tube holder. Then hold that in the fire. Then you will notice that after few seconds, it to start burning with a white dazzling flame. Means that flame is very bright, very bright. So that is why it is called white dazzling flame. Then after, when the burning is over, so it is available as a powdered mass that has been collected here. So this powdered mass is nothing but magnesium oxide. Followed? When the magnesium ribbon is burnt in the air, it reacts with oxygen present in the air and produces the compound called magnesium oxide. So, dear students, you have to leave space for drawing the figure and writing the procedure. Just one page is enough. You draw the figure, this figure. The textbook later. This figure should be drawn. Then after that, procedure. What is that procedure? First point, take a magnesium ribbon and rub it with sandpaper to remove the unwanted impurity called basic magnesium carbonate. Then next point, fix it to the test tube holder. Then place the magnesium ribbon in the Bunsen burner flame. Next point, it is observed that the magnesium ribbon burns with white dazzling flame and produces a powdery mass called magnesium oxide. Got it? After writing these points, then you will go for writing the chemical equation. That is magnesium and burning it reacts with oxygen and produces magnesium oxide. Here, the color of the magnesium, you know that this is silvery gray. Then what is the color of magnesium oxide? It is white. Please do remember, it is white. Followed? You'll write no? Okay. Next, this is an example for chemical reaction. Now we are moving to another part of the chapter, as I told in the earlier, that is, how can we identify whether a chemical reaction has taken place or not? To know that, we have some characteristics of chemical reaction. We have some criteria related to chemical reaction. Now let us come to know these criteria or characteristics. So just leave one page for this and write the side heading, characteristics of chemical reaction. Side heading, characteristics of chemical reaction. Characteristics of chemical reaction. Have you written? Okay, listen to me. Let us come to know about the characteristics of chemical reaction with some activity. Again, for that, I have made some charts as well. See, this is the first chart. In this, we have taken a test tube. It is fitted to an iron stand. Then we will take some pieces of zinc granules. Hope that you all can see that. Can you all see?
Sir.
Yes, sir.
Yes or no?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, okay.
Yes, sir.
Observe. Here, a test tube is taken. It is fitted to an iron stand. And in this test tube, I've taken some zinc granules. They are nothing but small pieces of zinc. Then after that, just go for adding dilute hydrochloric acid. On adding dilute hydrochloric acid, immediately you come to know the reaction will be taking place. How do you come to know that? When you observe the surface of the zinc granules, see, the gas bubbles will be coming out. Kansutalva?
Yes,
Can you
sir.
see these gas bubbles? Okay.
Yes, sir.
Yes, sir.
And these
Yes.
bubbles are filled with a gas. Then what is that gas? So
Hydrogen,
to know
sir.
that gas, we have, see that we are bringing a lighted mastic near the mouth of the test tube. When you bring a lighted mastic near the mouth of the test tube, immediately it produces the pop sound. This pop sound indicates the hydrogen gas is liberated. Here, hydrogen gas is liberated. When all the amount of hydrogen gas is liberated, at last we get a residue in the test tube. Do you know what is that residue?
ZnCl2.
That residue is zinc chloride. Followed. So in this chemical reaction, a gas is evolved. So in the chemical chain, in the process, if the gas is evolved, then you can say that the chemical reaction has taken place. This is the very first characteristic. The first characteristic is evolution of gas.
Evolution of gas.
Evolution of gas. If the gas is evolved in the process, then we can say that it is a chemical reaction. Artha aitala? And let me go for writing the chemical equation for this. Here.
Yes, sir.
Just look here. Here, zinc granules, they reacted with dilute hydrochloric acid and produces the compound called, it is zinc chloride, ZnCl2. Zinc chloride with the liberation of hydrogen gas. As the hydrogen gas is liberated, then we can say that here it is one of the characteristics to know chemical reaction has taken place. Next, let me go for taking another activity. Don't write afterwards. You mean matte nan points kortini. Just you have to write only evolution of gas. This is enough. Second one. Dear students, observe. Look here. Here, in one of the test tube, we have taken lead nitrate crystals. Then water is added to that. Then on shaking well, we will get a solution of lead nitrate. So it is aqueous solution of lead nitrate. Aqueous solution, if the solution is prepared by using water, is called aqueous solution. Here, this is lead nitrate solution. Do you know what is the color of lead nitrate? Lead nitrate solution? Lead nitrate solution, it is
White.
colorless. Colorless.
Less.
But when you take the lead nitrate crystals, it is white. Lead nitrate crystals are white in color. Lead nitrate solution is colorless. Similarly, next, in another test tube, we have taken potassium iodide crystals. Then water is added to that. Then when it is shaken well, it dissolves completely in the water and forms potassium iodide solution. Followed, Siddharth. Potassium iodide solution. Do you know the color of potassium iodide solution?
Yellow.
Yellow.
Change
No,
in
no,
color.
no, no. It is
Yellow.
also colorless.
White.
Potassium iodide solution is colorless. Okay. Lead nitrate, PbNO3 twice. It is white in color. Crystals are white in color. Solution is colorless. Next, in another test tube we have taken potassium iodide. Potassium iodide color, crystals color is white and the solution is colorless. Now, let us go for adding potassium iodide solution to lead nitrate solution, or else lead nitrate solution to potassium iodide solution. Here, when this colorless solution is added to this colorless solution, you'll come to know it will immediately turn to yellow color. Do you know
Change
what
in
is the
color.
reason for changing the color? It is because of the formation of one of the solid substance which is insoluble in the solution. Do you know what is that?
Precipitate.
It is called precipitate. Precipitate antandre, this is a solid substance which is formed during the chemical reaction and is insoluble in the solution. Chemical reaction admele namige a solid substance barutte, and this solid substance does not dissolve in the solution, and we call such a solid substance as precipitate. It is here the yellow color is formed is due to the formation of the precipitate. Then if so, what is that precipitate? Yavadu anta helidre here are right. Look here. It is lead iodide, Pb(I2), lead iodide, and remaining the solution is formed, that is potassium nitrate solution, KNO3 solution is formed. So this is yellow color precipitate. So the second one is formation of precipitate. In any chemical reaction, if the precipitate is formed, sorry, in any process, if the precipitate is formed, then you can say that chemical reaction has taken place. And one thing you must remember.
Sir, I can't hear, sir.
Yes, yes. Yes. Somebody was asking. Precipitate is formed under two conditions. This is one of the conditions. Look at this is aqueous solution of
Sir,
lead.
can't hear, sir.
Huh? Both are aqueous solutions. When aqueous solutions react with each other, then precipitate is formed. When two aqueous solutions react with each other, then precipitate is formed. Here, lead nitrate and potassium iodide both are aqueous solution. The reaction between these two has formed a yellow color precipitate called lead iodide. Lead iodide is yellow color precipitate. Right. Second one, formation of precipitate. Formation of precipitate. Next. Third. Listen. Your students, tell the chemical name of a substance whose common name is quicklime. In Kannada, what we say? Sunna.
Calcium oxide.
Yes, it is calcium oxide. Actually, whatever the calcium oxide is available in small packs in the market, it is actually slaked lime. But these are available. The initial calcium oxide, they are available in crystal. Here, I have taken some of the crystals of calcium oxide and take these crystals in the beaker. Then directly don't go for adding the water. You have to add the water along the inner wall of the beaker. And you will come to know that immediately the vigorous reaction takes place. And you will be able to identify the small sparks on the surface of the crystals of calcium oxide. Followed. Then when the reaction is taking place, you just touch the beaker. What happens?
Temperature.
Heated, sir.
You feel hot. Andre,
Change in temperature.
ಅಲ್ಲಿ heat produce ಆಗ್ತಾ ಇರುತ್ತೆ during this chemical reaction. Once I repeat, very simple activity. Take some calcium oxide crystals in the beaker. Got it? Then after that, you just touch it. You feel that it is at normal temperature only. Then you go for adding water to it along the inner wall of the beaker. Then the immediate reaction takes place between water and calcium oxide. That can be known by observing the very small sparks on the surface. And also you'll notice that the bubbles are formed. And it looks like a boiling process as well. When the reaction is taking place, just to test the beaker, you feel it is hot. Andre, you'll come initially that it was at normal temperature. Then during the chemical reaction, what happened? The temperature rises.
The temperature is increases.
In this case, heat is produced. Followed? So even if there is change in the temperature, this will also indicate the chemical reaction has taken place. Third one is change in temperature. Change in temperature. It may increase or decrease. First one is evolution of gas. Second one is formation of precipitate. And third one is change in temperature. Whatever the example I have taken, I'm going to write a chemical equation. You should not write, just observe. Calcium oxide was taken in the beaker, then we added water to it, then chemical reaction has taken place. Then could you tell the compound that has formed? It is slate lime or lime water.
CaOH2.
CaOH, calcium hydroxide.
Twice plus
Plus H2.
heat. Got it? This is the chemical reaction. When calcium oxide reacts with water, produces calcium hydroxide. Along with that, heat is also produced. Now, three characteristics are over. Now, fourth one, dear students, you may recall one of the activity what were conducted in 8th standard. That is, you had taken a beaker, in that the sky blue color crystals were taken. Could you tell what is that?
Copper sulfate.
Potassium.
Name the salt which is sky blue in
Carbon
color.
sulfate.
Copper
Copper
sulfate.
sulfate.
Copper
Copper
sulfate.
sulfate.
Then you prepared aqueous solution of copper sulfate. Then you will go for taking a nail and you'll rub it with the sandpaper. Then nail get shiny appearance. What is the color of the nail? Savanu? Color of the nail is? It is also silvery gray. Then you'll place that nail in the beaker containing copper sulfate solution and leave it for some time, about 10 to 20 minutes, and observe the beaker. What will be your observation?
Change in color, sir, from blue
Yeah.
to green.
From blue
Yes,
to green.
a sky
Change
blue
in
color,
color.
it will turn to pale green color. This pale green color, it is due to the formation of a new compound. What is that new compound?
FeSO4, sir.
Very good.
PSO4.
It is iron sulfate. That is FeSO4. You know the color of the crystals of iron sulfate. It is light green color. Is it not? Okay. Here I made one more chart. Observe, in the first beaker, we have taken some amount of water. First, we have taken copper sulfate crystal, then water is added. Then we have prepared copper sulfate solution. In first beaker, copper sulfate solution is there. Then we have taken a nail and it is placed partially in the beaker. See, some part is immersed completely in the copper sulfate solution and some part is above the surface of copper sulfate solution. Then leave it for some time. As I said, 15 to 20 minutes. After that, when you observe the beaker, you'll come to know that the color of the solution turns from sky blue color to pale green color. It is due to the formation of iron sulfate solution. And you'll also know that when the nail is removed from the solution, you'll come to know that
Brownish.
there will be brown coating on the nail. This brown coating is nothing but copper. Understood? Here, two substances are involved in the chemical reaction. One is iron, second one is copper sulfate. That can be written like this. Okay. Iron, it is Fe. Copper sulfate, CuSO4, copper sulfate solution. They undergo chemical reaction and form iron sulfate, FeSO4. Then copper get separated, which is coated on the iron nail. And you know that this you have learned as a displacement reaction in your previous class. In this chemical reaction, what actual thing happens is, here iron is more reactive than copper. It displaces copper from the copper sulfate and produces iron sulfate. As a result of it, copper gets separated. In this chemical reaction, you notice that the color of the reactants changes to the pale green color. Is it not? So even the change in color will also indicate the chemical reaction has taken place. Fourth one is
Change in
change in color, and it should be permanent also. Hangidre matra chemical reaction anta ಹೇಳ್ತೀವಿ. ಇಲ್ಲ ಅಂದ್ರೆ, sir, we will take some amount of water and we will add some color to it. Do you say that chemical reaction has taken place? No, ಅದನ್ನೇ ಹೇಳಕ್ಕಾಗಲ್ಲ. ಯಾಕೆಂದ್ರೆ it should be permanent change. So change in color is another indication of chemical reaction, another characteristic of chemical reaction. Next, one more is there. Dear students, just in the very first activity, we came to know about the burning of magnesium. Magnesium ribbon is a chemical reaction. Magnesium ribbon, it is a completely a solid. On burning, what happens? It reacts with oxygen and produces a bright white light and forms a white powdery mass called magnesium oxide. Okay. See, here, magnesium ribbon is taken, it is burned in the flame, then we got the white powdery mass, it is magnesium oxide. This is solid. Magnesium ribbon is a solid. What about magnesium oxide? That is also solid, but it has converted to amorphous form, andre powder form agi
Hash.
so hence we can say that
change
here
in state.
the
Change
physical
in
state
state.
has changed from solid to powdery mass. Clear up? So change in physical state is also a chemical reaction. Arthaitala? And please, and you also may be thinking that, sir, water gets converted from liquid to solid. It gets converted from liquid to vapor state. Can we call these as chemical reaction? No. Yakendre they are not permanent changes. Again, permanent changes. Once the water is converted into ice, can we get back the water?
Yes, sir.
Yes. If it is possible to get back, whether it is physical or chemical change.
Physical change. sir.
Physical change.
Physical change.
But in this case, whatever the powdery mass we have got, using this powdery mass, you cannot get the solid magnesium ribbon. Hangagi, it is a chemical reaction.
change.
Change in physical state is also an example for, is also one of the characteristics of chemical reaction, right? Change in physical state. Change in physical state. So in the examination point of view, they may ask the question like this. What are the characteristics of chemical reactions? Or how do you come to know whether a chemical reaction has taken place? Or what are the observations that we can make to identify chemical reaction has taken place or not? Then you will have to write these. First one is, please go through this. Look here. Aditya, one is evolution of gas. Second one is formation of precipitate. Third one is change in temperature. Fourth one is change in color. And fifth one is change in physical state. Clear? Now, dear students, we have come across many activities. Nearly 5 to 6 activities we came to know to describe the characteristics of chemical reaction. In those also, in one of the chemical reactions, we can identify more than one characteristics also. Let me give you one such examples and you should tell the characteristics that can be observed. ಅರ್ಥ ಆಯ್ತಲ್ಲ? In some chemical reactions, we can come to know more than one characteristics. ಒಂದಕ್ಕಿಂತ ಜಾಸ್ತಿನೂ ಇರುತ್ತೆ. Now observe. Here I am showing
Formation
you
of precipitate and change in color.
wait. I am showing you the chart in which lead nitrate reacts with potassium iodide. Then what are the characteristics that can be observed?
Formation of precipitate and change in
Formation
color.
of change in color.
Very good, very good.
Formation
Sir,
of
formation
precipitate.
of precipitate, change in color.
Sir.
Excellent. Two observations, two characteristics can be identified. One is, look here, there is change in the color. Here two colorless solutions were there. They changed to yellow color. Change in color, first characteristic. Next, in this, a solid substance is formed, which is insoluble in the solution. We call it as precipitate. So formation of precipitate. Did you understand? One is changing color,
Yes, sir.
second one is formation of precipitate.
Formation of
Now let me show you another chart. In this, what characteristics can be observed?
Evolution of
Evolution
gas.
of
Evolution
gas.
of
Gas and
gases.
change in temperature.
Evolution of
Change in temperature.
Change in temperature.
Evolution of gas is correct. What is another one?
Change in physical
Change in temperature.
Change in physical temperature.
physical state.
No.
Change in physical
Formation of precipitate.
No precipitate is formed here. Physical
Evolution of
state again
gas.
change agila.
Evolution of gas, sir.
Evolution of gas, it is quite common. Dear students, let me tell you one thing. Look here. Before adding dilute hydrochloric acid, you just test the bottom of the test tube. It will be at normal temperature. Then after adding dilute HCl, the chemical reaction will be taking place. During that time, you just
Change in
test the
temperature.
bottom of the test tube. You feel warm. That means
change
here,
temperature.
Change in temperature.
Change in temperature.
two characteristics can be observed. One is evolution of the gas. Second one is change in temperature. Adya, have you got it? Okay. In this,
Change in temperature
Change in
and change in
temperature.
physical state.
State.
other than that,
Temperature.
Change
Change
in
in physical state.
Change in physical state.
evolution of gas. Yeah, of course. Followed. Exam giving you one chemical reaction. Identify and write the characteristics of chemical reactions that are involved in the given chemical reaction are indicated. Dear students, now in the next part, what we are going to learn is we will go for giving just two examples with respect to each of these. Evolution of gas, formation of precipitate, change in temperature, change in color, and change in physical state. So generally discuss one. Evolution of gas. We are very familiar with this one. Please don't let this answer. For evolution of gas, just look at the board. Here, when zinc granules react with dilute HCl, hydrochloric acid, it produces zinc chloride, ZnCl2, with the liberation of hydrogen gas. Here, gas is evolved. Please look at the board. Next, you are also very familiar with a reaction of sodium with water. When sodium reacts with water, or when sodium metal is placed on the surface of water, it chemical reaction takes place very rapidly, very fast, and produces the compound called sodium hydroxide with the liberation of hydrogen gas. Even you may take zinc and sulfuric acid, Zn plus H2SO4 gives rise to, when zinc reacts with sulfuric acid, produces zinc sulfate, ZnSO4, with the liberation of hydrogen gas. And don't think that always hydrogen gas is liberated. Even oxygen gas is liberated, carbon dioxide gas is liberated, even sulfur dioxide gas is liberated. Avella chances irutte. Another example, okay, when carbon reacts with oxygen, then carbon dioxide gas is liberated. Understood? Artha aitala? So these are two examples for evolution of gas. Then formation of precipitate. For formation of precipitate, let's go for taking the same. Adya, let your concentration be here. Adya K. Bankapur. Ivenu baribardo, nan matte barastini, kelbekashte. With respect to formation of precipitate, when aqueous solution of lead nitrate PbNO3 twice reacts with aqueous solution of potassium iodide, then it produces the yellow color precipitate called
Lead iodide.
PbI2.
PbI2 plus aqueous solution of KNO3, potassium nitrate. So this is yellow precipitate. Followed. Next, another one. Aqueous solution of sodium sulfate. Recall the chemical formula of sodium sulfate. It is Na2SO4, sodium sulfate. Then I'll take aqueous solution of barium chloride. Devraj, are you understanding? Barium chloride, it is BaCl2. Both are aqueous solutions. The reaction will produce a precipitate. Do you know what is that precipitate?
NaCl plus BaSO4.
It is barium sulfate. And do you know what is the color of barium sulfate? What is the color of barium sulfate? Spurti A. Deepashri, yellow color nimage gottirbeku. This is white. White precipitate. Next, plus
NaCl 2N.
NaCl, not NaCl, just NaCl. Aqueous solution of NaCl. Once I repeat, when the aqueous solution of sodium sulfate reacts with aqueous solution of barium chloride, produces a white precipitate called barium sulfate. And this is a solid and is insoluble in the aqueous solution called sodium chloride solution. Clear up? Artha aitala? Okay.
Yes, sir.
Next, regarding temperature. Temperature, change in color and physical state. Let's go for taking two examples in the next class. Okay? And please do remember the chemical reactions what we come across so far. Avella you compulsory gottirbeku. You byheart madakagala. It is impossible to byheart any chemical reactions. You have to understand and write. You must. Yes.
Sir, after the class, send the recording, sir, so that we can revise it again, sir. Any doubt we have?
It is not always good. If it is much necessary, myself only will put that in the group only. Okay. Again, I have been telling, please recall today's class. One thing. Second thing, as it is chemistry class, while coming to the next class, before entering the class, without fail, you have to read and come. New textbook now open barlebek. And tomorrow also, you have to read at least first 6 pages. First 6 pages of your textbook. Okay. So with this, let us stop the class. Thank you very much.
Bye.